So we started this section by looking at the graph of 1 over x. This graph pictured in blue right here. And we considered kind of two different cases, the problems that have infinities in the questions and the problems that don't have infinities in the questions. We considered these end behavior type questions, but also these vertical asymptote type questions. In all the examples we've done since then, we've really only been considering end behavior. In this video, I want to consider the vertical asymptote type question. In order to do all the examples in this section, all you need is knowledge that you already have. 3 key facts. The first one just says if you're dividing by something where the denominator gets really close to 0, the fraction gets really large. I don't know, 5 divided by 0.0001, for example, is equal to 50,000. If the top is some constant and the bottom is getting really close to 0, the value of that fraction is getting really large. The other 2 facts that you need just deal with dividing positive numbers, and negative and positive numbers. A positive divided by a positive, as I know you already know, is a positive number. Similarly, a negative divided by a negative is a positive number. And a positive divided by a negative or a negative divided by a positive both yield negative numbers. And you're like, yeah, of course, I know that. Well, it's obvious when it's -8 divided by 2 or something and you get -4 as your answer. But things get a lot more challenging when you have 5 divided by -0.0001, for example. And you have to remember that that's not 50,000, but instead -50,000. The good news is we've kind of already done this. We saw this in the intro video. The limit as x approaches 0 from the negative side of 1 over x, we called that negative infinity. We came to that conclusion by thinking about the height of this hiker who's approaching our vertical asymptote from the left side. But really what we could have done is thought about this as 1 divided by some number that's getting really close to 0 but is negative. So 1 divided by -0.0001, for example. I have a positive number divided by a negative number, so I get a negative answer, and 1 divided by 0.0001 is 10,000. When my denominator gets really small, the value of that expression gets really large. A positive divided by a negative is a negative. Therefore, the limit as x approaches 0 from the negative side of 1 over x is negative infinity. Contrast that with this example, where we're evaluating the limit as x approaches 0 from the positive side of 1 over x. Now you're not thinking 1 over negative 0.0001. You're thinking 1 divided by positive 0.0001, for example. Now we have a positive number divided by a positive number, so we get a positive answer, 10,000 in this case. And the closer this gets to 0, the larger this will get. Therefore, the limit as x approaches 0 from the positive side of 1 over x is equal to positive infinity. Those ideas are the only facts we're going to need for this video. It's just not obvious that those are the facts we're going to need for this video. So let's consider some examples. The limit as x approaches 3 from the negative side of x plus 3 divided by x minus 3. I'm going to again use some non-standard notation because I think that makes this make a lot of sense for students. If my value of x is getting really close to 3 from the negative side, I'm thinking x is 2.99999 or something. X is really close to 3, but slightly less than 3. If x is really close to 3 and I add 3 more to it, I get this number that's really close to 6. However, if x is really close to 3 and I subtract 3 from it, I get a number that's really close to 0. And here's where I have to be really careful because I have to concern myself with whether that 0 is slightly positive or slightly negative. Because in a minute, I'm going to be dividing these two numbers, and it's important to know whether I have a positive divided by a positive or a positive divided by a negative. So let's again think about what's happening here. Because I'm approaching 3 from the negative side, my value of x is slightly less than 3. And if my value of x is slightly less than 3, and I subtract a full 3, I end up with a slightly negative number. I don't think this is standard notation, but I'm going to write this with a 0 and a little negative up in the superscript to remind myself that we're approaching 0, but we're doing so from the negative side. This is kind of like 6 divided by 0, but importantly, that's a negative 0 in big old air quotes. Think about these key facts. We're dividing by something that's arbitrarily close to 0, so our fraction is going to get arbitrarily large. We expect our answer to be an infinity when we have 6 divided by 0. But we have to be careful. Is it a positive infinity or a negative infinity? Well, 6 is positive, and this 0 is negative. as complicated as that is. So I'm in this positive divided by negative case. I get a negative answer. The limit as x approaches 3 from the negative side of x plus 3 divided by x minus 3 is negative infinity. To see if that made sense, let's evaluate the limit as x approaches 3 from the positive side of that exact same expression. Well, now my value of x is not slightly less than 3, but instead slightly more than 3. But for the numerator, I don't really care. The point is, it's really close to 3, and I'm adding 3 more to it, so I get a number that's really, really close to 6. It's the denominator where I got to be so careful. I have a number that's close to 3, and I'm subtracting 3, so I get a number that's close to 0. However, now my x value is slightly more than 3. Think x equals 3.00001 or something. If I have slightly more than 3 and I subtract 3, I end up with a slightly positive value. Instead of 6 being divided by a negative 0, loosely speaking, I have 6 divided by a positive 0. I'm still dividing by something arbitrarily close to 0, so the fraction's still going to get arbitrarily large, but now it's a positive divided by a positive, so I get a positive infinity, or just infinity as the limit. How about the limit as x approaches 3 from the negative side of 3 minus x squared divided by 3 minus x? Might not be a bad idea to pause and see if you can figure this out on your own. 3 from the negative side, I'm thinking 2.999. Something really, really close to 3, but slightly less than 3. When I take something that's really close to 3 and I square it, I get something that's really close to 9. If I have 3 minus something really close to 9, I get negative 6 up on the top. It's down on the bottom where I got to be careful. I have 3 minus something close to 3, so I have 0. But the question is that 0 negative or is it positive? Well, let's see. If my x is slightly less than 3, I'm thinking 2.999. If I have a full 3 and I get rid of slightly less than 3, I have a tiny bit left over. I have a slightly positive 0. I'm again dividing by something close to 0, so I'm getting an infinity as my answer. This time it's a negative divided by a positive, so it's this case, which results in a negative infinity as my limit. One more example before we call these videos good. Let's switch it up. Let's look from the positive side here, although really you can do it either way. The limit as x approaches 3 from the positive side of 3 minus 2x all squared divided by 3 minus x. Since we're approaching 3 from the positive side, we're thinking about 3.0001. Something really close to 3 times 2 gives me something really close to 6. 3 minus something really close to 6 gives me negative 3. So up top, I have negative 3 squared. In other words, positive 9. What about down on the bottom? Well, I got 3 minus something that's a little bit more than 3. If you only have 3 and you're taking away a little bit more than 3, you end up really close to 0, but slightly negative. So I have a positive 9 divided by, loosely speaking, a negative 0. I got a positive divided by a negative. I get negative infinity as my answer. As maybe you've gathered, these problems, they're really easy to confuse and mess up a negative sign somewhere and get the wrong answer, but they're kind of fun. They feel more like puzzles to me than they do like any tedious math thing. And I think more often than not, what goes wrong for students is more of an oversight than a conceptual misunderstanding. And for that reason, I'd really encourage you to write things up the way I'm doing it, even if that's non-standard notation. This 0 with the plus and the minus and the superscripts tends to work out really well as a way of showing your steps, which I find to be really important since it's so easy to make a minor mistake as you go through here. You don't have to do that, just my advice.